Otherwise, I will call Tim on the stand. Thank you, Tim.
So, my name is Tim Vriend. I'm with the engineering department with the AMS-IX. And I'm going to take you on a little bit of a, how do you call it, a tour in the life of the engineers with the AMS-IX. It is my first presentation today, so I'm a bit nervous. Please bear with me. First, we will go back a little bit to the SLX migration we did earlier this year. After that, we will also look into the implementation of the Huawei OSN solution. And at the end, I will give you a quick overview of the current roadmap. Well, let's get started. So, it has been written about already and discussed many times, the reasons why we went for the SLX. And, well, I would like to point out a few of these. First of all, the rack space. Of course, it's lower in rack space, 17U instead of 33U, compared to the AMS-IX E32 we used for the core switches. And it also uses half the power, which of course lowers the operational costs in running the SLX compared to the AMS-IX. The bigger reason, I think one of the most important ones, is the amount of ports at 100 gig that the SLX can handle compared to the AMS-IX. The AMS-IX was able to handle 64 ports and the SLX 288 ports, which is, well, 4.5 times more. And sorry, need to quickly check. In the past, we ran into the limitations of the AMS-IX, which already was mentioned. We had to introduce the subcores. And by going to the SLX, we pretty much can get rid of the subcore again. So this is the current network as it looks now, or as it looked before. We have the 4 core switches, the main cores, and the 2 extra subcores at the end. I'm a bit trembling. That you can see in the top half. And our plan was, well, we needed to make a plan on how to continue and swap the AMS-IXs for the SLXs. So we tried to make the simplest plan possible. And, well, it basically came down to, we will install the SLX next to the AMS-IX, and we would poke all the fibers over from the AMS-IX to the SLX, and do that 4 times until all the cores have been migrated. Once that was done, we could add some extra backbone capacity because we now had the ports available, and we could remove the subcores. And that makes it look like this after the migrations. Of course, as always, it's a very simple plan to discuss it like this, but it was not quite that simple. When we started looking at the current installation, we noticed that the cabling on the old core switches, it was pretty much cluttered over time. And the pre-cabling we had installed was not sufficient for the extra density of the SLX. Next to that, there was no space in the racks to install either the DCI or an SLX extra. So we could not just swap the cables over as we had planned. This did give us an opportunity to look a bit further. We found that we still had extra racks available, adjacent to each other, a bit further down the room in both core locations. And we decided to build up a completely new set, well, away from the production switches. And, well, that meant that we can do a lot of testing and everything without touching production. Of course, this also, I went already ahead of my slide. Of course, this also meant we did not have the problem of the cluttered cabling. We could right away tackle the pre-cabling problem and the cable management problems. And, well, we right away also had space for DCI and SLX implementations. We decided to split the SLX and the DCI into separate racks. First of all, because of the heat load and the power usage. And second of all, we figured that the DCI would maybe grow pretty fast in the future. Then it would still not fit into the rack together with the SLX. And here you can see the way we had it planned, and actually did install it as well. After we installed the SLX, we performed several tests, like always, to verify hardware. We started the documentation and planning, and we were told that this was the first time the SLXs would be used in production worldwide. So because of that, we decided to take it extra slow and steady, like Kostas already spoiled. Thank you for that. And on Wednesday, the 11th of January, we started our first migration of the first PE set. And actually, we did the first day, we actually did 2 PE sets to generate some traffic. After that, we left it running for a couple of days to monitor with NOC together. And eventually, on January 16th, we decided to migrate every single PE set we had on that core switch. And until, now I have to speak quickly. Until on the 2nd of February, we migrated the last links to the first core. And here's a little picture of it. We'll go a bit aside. Well, we didn't encounter many problems, or actually none at all. It went pretty smooth, like Henk already said. And therefore, we decided to speed it up. The first migration took us 3 weeks. And, well, we decided to just start a bit earlier, add some extra hours to our maintenance windows, and do multiple PE sets in one night. And we also started working with 2 men on-site, and then 2 NOC people off-site monitoring everything. And because of that, we were pretty much faster. And the schedule went from 3 weeks for the first migration to just over 1 week for every following migration. And well, the second and third migration, we did encounter a few minor issues, nothing bad. There were some QSFP optics, one batch, same serial numbers, that make some of the links flap. But after swapping those out, everything was solved. And at this moment, I'm pretty pleased to announce that the SLX has been running without any issues. So then we go back a bit more in time. And then we go to the Huawei solution. After some extensive testing of the equipment, the AMS-IX announced that last year we will be using the Huawei OSN range as our DCI solutions. The main reason for this well, was to simplify the network topology, to make installations faster, and same for the upgrades, and to make the maintenance easier, and again, also faster, and to reduce the operational cost, mainly due to the dark fibers and the connected cross connects to that. On the left, you can see the way we used to do our core backbones. Each PE set used to have either 8, 16, or 24 dark fibers connected to it, depending on the traffic needs. And on the, for me left, yeah. And on the right side, you will see the way it is now. Every PE site, so even if there are multiple PEs on the site, will only use 2 backbones, 2 dark fiber pairs. And from there on, it's pretty easy to add extra capacity. Once all sites have migrated, the total amount of dark fibers we use in the Amsterdam area will have come from a total of 250 pairs or more to just 28 pairs, which of course tremendously reduces the operational cost on that one with monthly recurring costs. So back in October last year, we received the first equipment from Huawei. And well, because it was the first time, Huawei also sent a couple of engineers extra to help us out with the installation. And later on, it proved pretty helpful. The configuration, which we started with right away in the beginning, seemed to be a bit harder than we expected. And well, with the help of the Huawei engineers, we were able to create some good documentation, right away got some little training on it, and we configured the first equipment. Then we started installing it, which, well, pretty much is basic installing, like any other thing. At least that's what we thought. During the installation, well, everything went pretty much smooth and fast, but eventually we could not get the link between the WDMs up. And after pretty much a lot of troubleshooting and quite some time, we found that the TX and the RX of one of the links was twisted. A very basic mistake, and it did not get caught by 4 pretty experienced engineers. At least, oh, wait, sorry. No. So otherwise the installation went pretty fast. So after we swapped the XRX back, and well, no big hiccups or anything. And I have to peek again. So in the months after the first implementation, Huawei updated the CLI, which make the configurations actually a lot better, faster, and easier. They also provided us with a full day of hands-on training on configuring, installation, and troubleshooting. They did this for the engineers and the NOC. We also did an upgrade. Actually, in March, I believe, we did our first upgrade. And where we used to have 2 months for supplying the dark fiber, the cross connects, the troubleshooting involved, this time it took us less than 2 days to perform a full upgrade. And that included a 24-hour stress test on the equipment. So the current status for the Huawei's, for the DCI implementation, is we migrated a total of 5 sets already. We also connected 2 new sites over the PEs, or over the DCIs. And we are currently in the progress of 4 extra PE sets that need to be migrated. This is because of the subcore. They need extra backbone capacity before we can take it over. And there are then still 5 PEs waiting. So what is next for us? Well, basically we are in the process of bringing up the POP, the 14 POP, the data center group, also already spoiled. And also spoiled the subcore decommissioning. So as soon as we have the last 4 PE sets covered on the DCI, we will be able to decommission the subcourse, which is at this moment planned end of June, middle of June. Then we have, for this year, we are planning on 3 more sites, the 3 busier sites where we need extra growth. We will implement the Brocade SLX instead of the Brocade MLXs that we have there. And we will continue the DCI solutions, the DCI implementations, which are planned at this moment to be finished somewhere early 2018. Pretty safe to say that we have still a lot of work to do. And I actually think that was it. Any questions? No? Then I'll pass the sticky to Erik, which is in there.